Hello guys, welcome you all once again for this AIML End-to-End session where we're going to learn a year-long content in order to become a successful data scientist. Hope you guys are enjoying this series. We are enjoying a lot. Every day we are learning and we are just teaching everything that we know. So guys, before going for this session, please make sure that you guys have a thorough understanding of what we are teaching in previous session. So please go through all the videos that are done till the previous session so that you have a better understanding of what we are teaching now. So guys, like in the previous session only we have dived to the different topic. Rather than data, now we have dived to a model, machine learning model, and we have introduced some important things, types of machine learning model, and we have covered supervised learning. Okay, today we will start with unsupervised learning. Okay, so guys, please look into the previous session because like then only you can have a flow of this session. Okay, so let us dive into this session. Okay, unsupervised learning. So unsupervised learning algorithm learns from the unlabeled data, discover patterns and structures without explicit guidance. So I have already explained to you. Okay, so the thing is, if you have a data without any label and the model train itself, then it is called as unsupervised learning. The same example I'm going to say: you are having an apple and you are having a banana. Mission itself took the apple and just seeing it, okay, it is in red color and it is in circle shape. So I'm just going to keep this to one category. That was the mission says. And it takes the banana and it sees, okay, it is not in circle shape, it is in yellow color. Okay, I will put it in different category. It will just categorize, that is cluster the things, but it doesn't know the exact name of it. This kind of labeling is called as unlabeled data, and using this we create a model which is called as machine learning model by using the technique called as unsupervised learning, because it doesn't know what it is, but it is doing the clustering. Okay, that it is finding something. Okay, so that is what, guys. So one of the, so this is what all about unsupervised learning. Let us see some of the types in it. Okay, clustering. So it is one of the unsupervised learning technique where we will be cluster the data based on their characteristics, as I mentioned now. Dimensional reduction, actually you guys have already know about it, because like high dimensional data to low dimensional data, where it is used to reduce the number of features that we are having. If we are having 1,000 features, then if from the 1,000 feature, if 10 features are important in order to predict the target, then we can go for just a 10 features. Okay, so that is what dimensionality reduction. Then guys, there comes our association tool. Actually I love this very much, because all the recommendation system are built on top of it. What it does means it discovers the relationship between different variables in the data, identify frequent patterns and co-occurrence. So there is a popular example called as market basket analysis. Okay, so it is like what a person can buy if he or she buys some product. Okay, for example, if a person buys milk and then a butter, then the second person comes and buy milk and biscuit, then the third person comes and buy jam, then there is a high possibility he or she can buy a milk, because the milk is bought by the two persons before that. Okay, it is like a association rules, guys. So this is what a base on a scratch thing for creating a recommendation system. Today we guys are having everywhere recommendation system. If you guys are opening your YouTube, right, you guys will be getting recommendations based on the scenes or videos that you are just watching previous. Okay, so this is what all about the supervised learning and the types we are having. Yes sir, over to you.
Yes, great. So, great explanation. So, we are enjoying these sessions. Kindly write in the comment section how you are learning these things and these concepts, and give us feedback how to improve. And watch all the sessions from beginning till end, all the 5 to 10 times. Do reinforced learning, absorb the information, digest the information, and apply, and do all the assignments. So let's jump into supervised learning. So supervised learning is just algorithms learn from unlabeled data. So unsupervised learning, sorry. Supervised learning, we algorithms learn from the data which is labeled, but unsupervised is where the data is not labeled, unlabeled data, okay? Discovering the patterns and structures without explicit guidance. So this is the difference. Like unsupervised learns from the unlabeled data. This is how you can remember. And supervised learns from the labeled data. Okay. So Clustering is a group of similar data points together based on their features, relevance, hidden structure in the data. So we have to see all these, and based on that, we do clustering. So uh, dimensional dimensionality reduction, we already know this concept, simplifying data by reducing the number of variables so that uh, the performance of the model will improve, okay, making it easier to analyze and visualize, okay. Then association rule learning is discovering discoveries relationships between different variables in the data, identifies frequent patterns and co-occurrences. So this is you would have seen in recommendation systems and other places. So association rule learning. So there is an associativity between the variables and different variables. They will find patterns and reoccurrence, co-occurrence, or whatever, and then based on that, this thing happens. Okay, let's move to the other slide.
Yeah, sure, sir. So next we're gonna see reinforcement learning case. I think this is the third type. So reinforcement learning algorithm learns through trial and error method. It receives the feedback in the form of rewards or penalty based on its action. So guys, I will just go through these terms and I will explain with an example. Okay, agent, the learning system that interact with the environment. Then we are having environment, the context in which the agent operates, provides feedback through the like reward or penalty. Action, the agent perform action in the environment aiming to maximize its reward. And then we are having reward, positive feedback provided by the environment for the action that leads to the desired outcome. Learning, the agent updates its policy based on the reward and penalty received, improving the performance over time. Okay, guys, these are the technical terms. I'm gonna explain it by using a very scratch method. Okay, consider any game. Okay, I think you guys know about Super Mario. Everyone would have played in their childhood. Okay, so in Super Mario, like there is a character called as Mario. Okay, that is called as agent. Okay, and where you are playing, right, there will be like a mountain kind of thing and we will be having some stones kind of thing and we will jump. That environment is called as environment. That kind of environment, we will be having some coin will be there and some stones, bricks will be there. Those are called as environment. We have an agent, we have an environment. Now agent gonna interact with the environment and based on the interaction gonna be getting the punishment or reward. And this is what entire thing the called as reinforcement learning. Okay, we have a agent Super Mario and the environment which is it is playing is called as environment. Next, action, what we will be doing with the like Super Mario, like the character that is the agent, we will be moving left, sorry, left, right, up, down, right? Those are called as action. Next we are having rewards. So guys, you can remember like whenever we break the brick, there will be a coin will be coming out and we will be getting, and there will be some tortoise, right? If we break that, then our life will be like penalty. Okay, so whenever you get the coin, it will be like a reward. Whenever you hit on a tortoise, it will be like a punishment. So this is what all about the rewards. Next, learning. Okay, first time you play, okay, you gonna touch the brick and you will be getting the reward coin. Okay, like you will do the same thing to the tortoise. You will touch it, your life will be close. Okay, next time what happens, if you do that, you already know, okay, if I touch the brick, if it is a coin, I can take that. If it is tortoise, I should not touch it. Okay, this is what called as learning, but this learning is done by us because we know the scenario. But in machine learning, it is done, or in reinforcement learning, it is done by the model itself, because as a human learn from the past experience, the model will also learn. Okay, guys, this is what a simple example. It is a perfect, I will say, not like a perfect, it will be like a like like a, I will say, school level understanding of this reinforcement learning. So it will be very very helpful, guys. So this is all about reinforcement learning. Yes sir, over to you.
Yes. So reinforcement learning, again, we know we reinforce the learning And in machine learning, first is agent. Agent, what is agent? Agent is learning system that interacts with the environment. Okay. And interacts with the environment and also improves also. It learns from the environment. Huh? It will also learn from the environment and improve the performance. Then, environment. What is the environment? The context of which agent operates. So suppose you have a robot, cleaning robot in your house. So you have a space like room, lobby and all. So you will, the environment is that particular room to clean, okay? A robot who is on the border with army, okay? Fighting robot. So his environment is different. It's border. He is designed for that, okay? So every agent is designed for specific purpose and the environment as per the environment. So that is why it is very important uh, for reinforcement learning to what kind of environment, huh? What kind of intelligence, huh? Then provides feedback through rewards and penalties. If suppose you have a robot which is on the border and it kills the enemy while infiltrating or something, so you give reward, and if he's not taking the action as per the system designed, the desired output, you give a penalty. Huh? So this is how reinforcement learning happens. The environment is, then we have action. So the agent performs actions in the environment. Okay, I told you, like it depends. A robot, cleaning robot has a different environment and different system also designed for that action. So every agent will have different environment as per the objective function. So aiming to maximize the reward. So action is always agent will be performing well so that he will get reward. Otherwise he will get penalty. So reward is what? Positive feedback provided by the environment for action that leads to desired outcomes. This is what is reward. Then learning, what is learning? The agent updates its policy based on the rewards and penalties received, improving the performance over the time. So reinforcement learning is also used in chat GPT, guys. So you will see there is option like ha, like thumb button, hand like thumbs up or thumbs down. You will see that. So it will ask you for the feedback. So that is the learning, right? You will give feedback. So agent tries to improve the performance. Based on the feedback, it will try to keep learning, keep learning. This is how that is one of the algorithm they use. They use combination of different algorithms in chat GPT, but reinforcement learning is one of the, because it always keeps learning, reinforcing, improving based on the feedback. This is how it happens. Thank you. Let's move to the other uh, slide.
Yeah, sure, sir. Next we're gonna see application of machine learning. Now you guys have know, like there is no industry without machine learning. I will say, okay. So machine learning has a numerous applications across various industries, revolutionizing how we solve problems and make decisions. That's a major thing, right? So today we are solving problem with less time, less amount of manpower by using only machines. Okay, that is what the, I will say, that is what the gift given by the this field of AIML. Okay, first is self-driving car. Like I think you guys have already know about what is self-driving car. The machine learning algorithm enable autonomous navigations and decision making in self-driving cars. So this is one of the application. And we are having medical diagnosis where it assists in diagnosing diseases and preventing, like predicting patient outcomes, improving healthcare outcomes. So the thing is, if a person is gonna be suffer from cancer, if it is known by the doctor, like in a earlier stage, by using this model, it will be very easier for them to cure. At least they will protect the life, right? Then there is a financial forecasting, like machine learning algorithm or models analyze market trends and predicts financial performance and aid in investment decisions. Okay, the thing is in financial industries, like I think in more like in stock market kind of thing, we can what we are investing, what we need to invest, what will happen in the future, like those things we will be doing. We can get a clear understanding by using this machine learning algorithm. Finally, robotics. Okay, this machine learning algorithm powers intelligent robots that can perform complex tasks in various industries. So robots is like it is a replica for a human, right? So it is gonna be how human like human gonna act in the environment. So those things are done by these missions. So I think it's not limited to here. There are different fields, like we are having education, where like this machine learning is doing a lots of things, agriculture, and there are numerous applications, guys. So yeah, we will not able to limit by this only four things, because this slide can able to accommodate the only four field. So I hope like now you guys have an understanding of there is no limit for this machine learning or AI. Okay. So yeah, sir, over to you.
Yeah. So application of machine learning is there are n number of fields where we can, like I'll tell you how I can define it. Wherever is the data, and if you can clean and pre-process that data and build models and use machine learning algorithms in any field, I'm saying any industry, if you have this criteria, you can use machine learning everywhere. The criteria is, can you get the data, can you have a good data, and can you clean it, pre-process it, and create models? And as per the data science and machine learning models, algorithms, if you can do that, you can use machine learning in any field. If you have these things with you, data. Okay. Now, so the application is in various fields we can. So here are some examples. So self-driving cars, machine learning we use. Also, we use deep learning, computer vision, right? So we use it for autonomous navigation, decision making, self-driving vehicle. We use it, okay? And like there's an example of Tesla, and different companies are coming up with self. Google is doing a lot of research on self-driving cars, and other companies also. So, next is medical diagnosis. So, machine learning assists diagnosis disease, predicting patient outcomes, improving healthcare outcomes, and also we can use it for predictive analytics. Like we can predict the if you have these habits, if you have this kind of disease, so how you can cure it, or if you might have in the future. So we can predict based on the data, medical history, or other data sets, we can predict that how people can proactively work towards proactive healthcare rather than reactive healthcare. So using data, using models, using machine learning, we can go into even healthcare has a very big it's an ocean, huh? So it's a very big sector. You can use it in different fields. Financial and forecasting. Again, financial is a big field. Trading, stock market, banking, applications, forex trading, crypto. A lot of sectors are there, huh? Subsectors of this. So in machine learning can predict the trades, predict the financial performance, fraud detection, investment decisions, lot of things we can use in machine learning. That's why we are learning it. Robotics. Machine learning can power intelligent robots that can perform complex tasks, various industries. Okay. It can be defense, it can be labor, it can be any tough jobs, blue collar jobs, which people like cleaning, lot of stuff we can use it. And there are numerous fields in robotics we can use machine learning, and other fields wherever we can generate data and we can try to automate and improve the optimize do the optimization and achieve the better performance. We can use machine learning everywhere, wherever. So because machine learning learns from data, so if we are generating data and we can optimize, automate, or get the better performance, we can apply machine learning. It's not that thumb rule that you can only apply machine learning in this industry or not other. Keep experimenting, keep inventing and working and iterating. You will find way, no problem. Thank you. Let's move to the other slide.
Yeah, guys. So final thing like challenges in machine learning. So while powerful machine learning faces challenges related to data quality, algorithm bias, and then ethical consideration. Okay, first we see data quality. Okay, ensure the accuracy and completeness of the data is crucial for training reliable models. Like, this is what we guys are discussing, like sir and also myself. You need to make data very accurate. Then only you can expect your model to do whatever you tell. Okay, without having the data ready for your model to do, then nothing is going to be happening. Okay, next is algorithm bias. Bias in the data or algorithm can lead to unfair or discriminator output. True, right? If you are having bias in the data, or if you are having bias in the algorithm, if you have a bias in data, it directly going to affect the algorithm. Algorithm going to be biased, and the outcome is also biased. So everything starts from the data. Do the data in a manner that it is not becoming biased, and try to, so if it is not biased, algorithm also not biased, and we will get the proper output. Okay, next, ethical consideration. Addressing concern about the privacy, security, and responsible use of machine learning technologies is very important. Okay, so guys, one thing, we are all depend on the data. So we should have a proper understanding of whether to use data, what data we need to use, first of all, where to use, when to use, why to use, and this kind of question, and to whom we are using it, and from whom we gonna get the data, and what kind of agreement we are having. So guys, these things are very baseline whenever you go for the analysis. Okay, so these are the challenges that we will be facing in machine learning. So yes, sir, over to you.
Yeah, data quality is very important, guys. So we have to understand it's a crucial thing because your data, garbage in, garbage out. Whatever you are giving the input, you will have the output performance according to that. I'll give example. If you eat unhealthy food and that is input, huh? And then it will go inside your stomach, everything, your system function will happen. Degradation, lot of stuff, chemicals, HCl will get absorbed, it will degrade, it will separate energy, the blood, all these things, it will go to different, there's a complete system, right? We take it very lightly. That there is a, we take input, there is a function inside happening, and then there is an, and the output is, it can be energy, and if you have taken unhealthy food, what will happen? Output would be your health will deteriorate. You will not have sufficient, you will not have good energy, you will not think positively. And similarly, if your data is not clean, it is quality is not proper, consistency is not there, if it is biased data, your outcome, the output will be same. So you need to always think that uh, your data quality is always uh, it's a very crucial for your model. I'll say this is the most important part of your machine learning model when you're creating a model, and this is the biggest challenge. Then we have algorithm bias. So bias in data or algorithm can lead to unfair or discriminatory outcome, which I said again, data is very crucial. If it is biased, garbage in, garbage out. Okay. So whatever you put, if it is quality data, you will have quality output, but you have to also use right algorithms. It's not data only, but you need to use right algorithms. You can't use, if you have to use nearest neighbor, you start using logistic regression or some other algorithm, so that would be very funny, huh? it would be very funny thing for a model to train. So we need to know those models. We need to know all these algorithms in and out, limitations of it, so that we can use it for right data. According to the characteristics of data, we use the algorithm and the objective function of the model which we are building. Okay. Ethical considerations. We need to consider the ethics, approval, privacy, security, being responsible to technology, you're being ethical machine learning, I'll say. So ethical deep learning, ethical AI, this is what you need to consider. So being very, very, and also learning the laws, secure IT laws, because then when you are going to deploy these models, these applications, so it should be congruent with the laws of the country, law of the land. You can't build, suppose for India, there are certain laws. If you go to America, collecting data is a big thing. You need to take approvals. Otherwise, there's a lawsuit. So Europe, different laws. So when you're considering this, so each country has, so you need to consult the legal authorities, government, other people, take inputs, take approvals, and then have these security, privacy, and all data integrity concerns to be covered. First, prepare your all documents, everything, be prepared and don't violate that, and then you're successful. These challenges you need to consider to be a successful AIML engineer, data scientist, AI researcher, AI scientist, or deep learning scientist. So these are common for all. Like these challenges are, they are the base of um, any AIML model or data science or any, because these are very, very fundamental. So remember them. So go through all the sessions 5 to 10 times, absorb the information, digest the information, and apply. Do all the assignments which are given, and don't come to this session, go back and watch all the sessions, then you'll understand what we are talking. Otherwise, it will go above your head that what they are talking, agents, learning, environment. So you thought this is the ecological environment. No, here the environment is defined as per the agent. So there are a lot of minute things. So that will go above the head. Why I'm saying that way? Because then you will not understand. Because we have discussed deeply in the previous sessions. So go through it, and then you will understand. And subscribe to our channels and give us feedback how we can improve these sessions each time. Thank you.
Yeah, guys, that's it for today. Hope you guys have enjoyed this session. Let us meet in the next session. Bye, guys. Take care.